And this is the installation video for the Count Easy Creaser. We're starting the video at the point that you've removed the machine from the crate and you've identified the parts. So in the crate, you should have the exit tray, the set of Allen wrenches, and your 2 side rails. Okay, the first thing we're going to do is install the rails. So as I said before, you have 2 rails. There's a left and a right rail. Okay? So to install them, it's very simple. Just loosen
lock nut.
Loosen the lock nut.
Turn the thumb screw until the shaft comes out.
So we're loosening that until the shaft comes all the way out past the threads. Move it off the machine. Put your left rail on first, then your right rail. Sometimes you have to loosen those red knobs a little bit to get the shaft through that hole. Once it's all the way on, just spin the shaft and retighten. Just get them approximately in place, tighten the red knobs till just a little bit snug, and the rails are on.
Scoot back up just a little bit.
The next thing we're going to do is install the receiving tray. You'll note that on the back of the machine there are 2 pins. The receiving tray goes over the first one and just behind the second one. Avoid the temptation to push the receiving tray too far in. If you try to put it underneath the wheels, you'll cause a jam. You have 3 stops with magnets. Just apply them anywhere on the receiving tray for right now. We're removing the side covers of the Easy Creaser to show you some of the inside components.
Here's the drive system for our Easy Creaser. We use very fine teeth MX belts, so we're very accurate with the location of where we put the crease on the machine. The way we do put the crease on the machine is we're not actually looking at the piece of paper. The sensor on the machine is basically an on-off switch. As soon as that sensor is blocked, the brain starts counting steps in the motor. We're using a stepper driver motor. So if you're doing a half fold on an 8.5 by 11, that's around 1,200 steps. The machine is going to move 1,200 steps, stop, crease, and take off. So if that crease is jumping around, it's because something is usually affecting the paper, or a belt is starting to go bad. You'll end up losing a couple of teeth, and that will cause our drive system here to not spin correctly. So it's really important to know exactly how the paper is being read as it's going through there, and how we judge distance. So this is our main drive motor right here, and here's the belt that runs our first shaft and our exiting shaft. This right here runs our feed wheel. It runs slightly slower than everything else. But the feed wheel itself, that shaft, is on a one-way bearing. So that as soon as the paper gets to the black rollers take it and pull it through. So our machine, as you can see, very, very simple, real easy to understand what's going on as long as you know how it operates. So that's the entire drive system here. We've got 2 pulleys right here that are idler brackets. You'll loosen those, that bracket will pop up, this bracket will go down, and the belt can come off very easily. So that's all there is underneath here. This right here is the chain that runs the creaser. We use a DC gear drive motor, so if that creaser isn't spinning around, usually the motor has been broken. They get a major jam in there or try and crease 4 or 5 sheets at a time that are really thick, the motor is meant to break so that we don't destroy anything else in the machine. So that's everything underneath here. As for the electronics underneath this side, here's our stepper motor, here's our driver, and we've got 2 power supplies back there. A 24-volt power supply that runs all the electronics on the machine, and the 48-volt which runs the driver that runs the motor. So that they're on separate things, separate circuits. So if the motor is not working, the first thing we're going to do is look to see if our lights are on the power supplies.
That's the one over there for the motor.
No, this is the 48 right here.
That's the 48?
Yeah, this is the 48. They're both marked. So if this light is out, we'll know that this is the one we need to replace. You'll start to pull it out, tell me it's a 48. We send you out the 48, you put it in, you're back on. Same thing with the driver here. We've got lights on it that'll tell you whether it's working or not. Inside the center here of the driver, there are these blue and white dip switches. Make sure that you inform customers never to change those. It'll change the rate of speed of the machine. Also, if the machine is on and they change it, it will burn the driver. We have the PLC, which is the brain of the machine. This right here is our HMI, which is the touchscreen controller. Again, everything has lights on it. So there's a whole series of lights behind these green plugs. If there's a problem with the machine and none of the other lights are telling us that it's not working, what we'll do is I'll have you pop this off right here and we'll look at the red lights behind there. See the red lights?
Oh, yeah. Yeah.
Those red lights are input and output lights. They tell us exactly what the machine is doing, or what the PLC of the machine is doing. So it's, it tells you whether it's sending a signal over to the HMI. If when you hit the run button, a different light will come on. So this is everything for us that we need to diagnose what's going on with the machine. So it's as simple as that. Put it back in. Put the bottom in first. Rock the top in place, push down the white clip. This right here is our relay for the motor, for the crease motor. Now, the way we activate the crease motor is the relay will turn power onto it. It goes around until it hits this switch right here. That switch now tells the PLC that it's found home again, and what we do is we reverse the power in the relay, so it reverses power to the motor really quick, and it breaks it immediately, so it stops at a home position every time. In doing so, that causes a little bit of a problem with the relays. We're working on a better relay for it. But every so often, the relay will get stuck. The motor keeps running and running and running. You take any one of the Allen wrenches that come with the machine.
Give it a tap.
It's fixed. It's that easy. And if that happens, I'll tell people, tap on the relay. That'll get them through their day. They can order a new relay. It takes a couple days to get parts from the factory. You put it in, just unplug it, plug the new one in exactly the same way. Remove one screw, it comes off. You put the new one on, screw it in place, and you're done. Okay, this is our rotary actuated creasing. We have an upper eccentric shaft here that spins, pushes down on these two blocks in the bearings, which push down the upper crease duct. This is factory set. We don't want anybody really messing around with it. I can't help it when they do. If you do have an issue with it, if a bearing breaks on it, which has happened, you'll end up giving me a call. There's these two set screws here that you have to loosen on the face, these lower ones, and that'll allow that to be adjusted up or down when you're setting the depth of it. But we really don't want people messing around too much with that, because too much pressure on there will end up creating too much pressure on the motor, breaking the motor sooner, wearing it out. Our rails move just that easy. So you move them into place.
Okay.
The machine, it does register itself on this side, because this is where the sensor is at.
Okay,
so as long
on
as
the
the paper,
left-hand side,
yeah,
okay.
as long as the paper is going underneath this yellow sensor, right in there.
The yellow one. Okay. All right.
So yeah, the paper just barely needs to nick that. Now underneath, that sensor is shooting down to this piece of reflective tape.
Okay.
So if something's covered that tape, it's
Stop.
not going to register.
Yes.
It's not going to see that piece of paper. So if something's not working or if it's not counting, look down here first.
Okay.
It happens quite often. As the paper gets stacked up, this lower roller here will catch it and pull the sheet back in here, and you won't even know it. It'll drop back down here. It'll get forced back up here and go like that underneath.
Okay.
And you won't even know it's there. So if something's not working right, look under there first. If there's no piece of... Here we're going to square the rails. So we'll start with the operator side rail first. Slide the piece of paper all the way forward. Come back around to the side. So that our sheet is squared to the lead edge of the friction plate. As you can see, we're off a little from one side to the other. What I'm going to do is unlock the rail up top and turn the adjustment screw counterclockwise until our sheet is even on the lead edge. That's over there. Then after that, we will lock the lock screw and bring the non-operator side rail into play. We'll make an adjustment here as well so that our sheet is squared.
Nice video.
On this sheet, as you can see, we have one perforated line cut through it already, and next to it we have drawn lines to where you might want to have the perf at. On the back side of the rails, the bar that controls them, there is an adjustment screw which allows us to micro adjust where the perf needs to go. You'll change that by locking this, unlocking here, sliding your sheet in, and moving moving this adjustment screw here moves both rails over at exactly the same time, allowing you as much as half an inch of movement in either direction without having to adjust each rail individually. And as you can see, we've moved the perf over from one location to the next. Here are our upper assemblies. This is a roller assembly and it is spring adjusted. There is no need to adjust the wheel when you have it put in place. Here's our perforator. It does have an adjustment screw on it that allows you to lower it down and back up when not in use. These down here are our lower assemblies. Here is a lower forwarding roller. Each one of the lower assemblies has a brass tip set screw in it. It must be a brass tip set screw every time. Your sheet, your roller should be about half an inch in from the edge of the sheet so that the paper is right there on the edge of the silver part of the roller. The other rollers should be evenly spread across the sheet. The perforator, this is our lower perf hub. It is an anvil style perf, so the blade will ride on the chrome section of the perf. You'll always want to have the perf blade ride in the center of that chrome. Underneath that chrome there's a rubber ring that will tilt if you're running to either side or the other. And a tilted lower perf hub will cause a radius in the perf.
Yep. Go ahead.
To put the upper assemblies in place, you'll want to get the set screw in the channel while the rubber roller is set on the roller evenly. And just lock it in place, and now you're ready to go. Having the black rollers on the sheet spread across evenly will guarantee the piece of paper registers through the machine straight. Also, having as much black rubber on the piece of paper will guarantee that the page will register while creasing exactly the same every time. So it is very important to run the machine with as much of the black rubber on the sheet as possible. 4 on the feed side, 2 on the exiting. To lower the perf into position, use your wrench. Make sure this thumb screw is turned all the way to its highest point. Turn the perforating adjustment screw all the way until the perf touches the lower assembly. Once it touches the lower assembly, turn the adjustment screw half turn past that point. Lock the thumb lock, and you are ready to perforate. This is the HMI unit. It is basically the heart and control of all aspects of the machine. To perforate, all you'll do is put it in perf mode, fan your papers out correctly, and push run. This is a top feed friction machine, which means the top sheet is what gets pulled through first, so you'll need to fan the sheets in a manner that will allow that top sheet to be pulled through first. Take your sheets, lightly tuck them under the blue wheels, and lay down the rest of the stack. Put the machine in perf mode and push run.
It's okay, I just want to record. Good.
All right, in crease mode, we have 11 different preset types of creases. The half-fold, tri-fold, Z-fold, letter-fold, and then we go to more, which gives us the roll, gate, and double parallel, as well as 3 different type of perfect bind hinges, where all you'll have to do is tell it how thick the spine is, and then each one of the different type of perfect binds. On top of that, if we go back, we always can go to custom, which allows us to crease in 12 different locations.
That's it.
For running any crease job, you'll select crease mode. The type of fold that you'll need, we'll go with tri-fold. Take 1 sheet, drop it in the feeder, press start measure. He's now measured the sheet. We accept that and press run. For the custom mode of creasing, you'll select which crease is always from the lead edge to the first crease, lead edge to the second crease, lead edge to the third crease, and as far down the sheet if you're using all 12. So you'll select crease 1, tell it 50 millimeters, press enter, and then we can press accept, and it will now do a single crease at 50 millimeters. On the home screen here, or the crease mode screen, we have an adjust button. That brings up a number that is not actually relevant to any type of measurement. That's how many steps it took for the machine to get from the lead edge to the first crease. That number is how many steps in the motor it took. So if you need to move over by 1/2 millimeter, you would move that over by about 4 steps up the sheet or down the sheet. Press accept, and you have now adjusted your crease location. As well, we also have a batch count button. I know it says it's on, but it's really not. That is the button that tells you where to push to turn it on. You would put in what you want for the batch, press enter, turn it on, press the accept button. The machine will now run 500 sheets, stop, and let you know that the batch is complete. To turn it off, come back to the batch count button and press the off button. Press accept and your batch counter is now off.
Crease test.
The crease test button is for technical support issues. If your machine is not creasing correctly, we will have you test this button and it will fire the crease bar telling us that the motor is working correctly. The parameters button is password protected and is something that is used during technical support issues for us to check parameters on the machine. The counter reset button does just that, resets the count. Then we have our jog forward button and our jog backwards button. What those are for is if you have a jam in the machine, you can use the jog button to get the piece of paper out of the machine. The feed delay button is used when you're using the machine into a UV coder or some other type of machine where you can slow the machine down between sheets so that the other machine has time to feed. The larger the number, the larger the delay. The lower crease die has two sides to it. You'll take the bar out. Anything above 9-point paper, you'll want to flip over to the wider side. Slide the bar in slowly so that it does not get jammed. With a little bit of a wiggling motion to it, allows it to slide in smoothly.